Please welcome Marcel.
Hey. We're going to talk about parsing PHP. Yay, everyone's hyped? Cool, okay, yeah. Awesome. I know we all learned a ton during the last 2 days, so parsing PHP might not be the easiest or lightest topic, but we'll go through there, don't worry. I'm Marcel Pociot. I'm the CTO at Beyond Code, which is just a fancy word of saying I'm the co-owner of a three-people company. You can follow me on Twitter or X or whatever if that's your thing. And at Beyond Code, we create software tools that help Laravel developers, PHP developers. So most recently, Laravel Hurt, which is now coming for Windows as well. We also do open source, so for example, Expose. So if you ever ran herd share, value share, sales share, then this all goes through open source, through Expose, which is like a PHP tunneling solution. So it allows you to share your local URLs with others. It's entirely open source. You can host your own server if you want. You can give us money. If you don't want to do that, that's fine as well. We also have Tinkerwell, which is like a PHP artisan Tinker UI, and other cool stuff that you might want to check out. So, I like to do sort of weirder stuff with PHP, and I like to sort of bend PHP in kind of weird ways. I just like to explore with the language, so I hope to take you on this journey and you learn something along the way. It's something there? Okay, cool. So, this talk could also be called Tinkerwell Behind the Scenes. Don't worry, this is not going to be an advertisement. For real. But we're using a lot of PHP parsing in Tinkerwell to make some of the cool stuff work behind the scenes. And that's kind of where I got really inspired about using the PHP parser and make it work. So that's kind of where I got the idea for this talk. Now, to get us all on the same page, what actually is a parser before we look at any code? So a parser can basically be split up into two sections, so to say. So the first one is what is called a tokenizer. So if we have this PHP code, which is just some random string sitting in a file on our computer, if you think about it, then the tokenizer takes this string and, well, it turns it into individual tokens. So if we just take this as an example, we give it to the tokenizer, and we end up with tokens that look like this. So we have the open tag for our PHP file, we have some white space, we have an echo statement, more white space, then we have a what's called a constant encapsed string, because we're echoing a string, not a variable, and then we have the semicolon. And you can do this, so this happens under the hood when you use PHP, but you can also do this in userland PHP code. So we can use the PHP token class in PHP, use the tokenize method, give it some string of PHP code, and then we get, as a result, this array of all the PHP tokens. These tokens have an ID, which then basically reflect to the T underscore constants. They have a text with some value in it, and we also have some information about the location of this token within our source code. So with this basically flat array of tokens, we can then give it to the parser, which then takes it and transforms it into an abstract syntax tree, or what's short called the AST. So as an example, with this echo hello LARACON PHP script, this is kind of what the AST looks like. So as it's called an abstract syntax tree, it has a tree-like structure. The root node is, in this case, the program. And it has multiple children. In this case, it only has one child because it's just the echo statement. And then we get information about the individual nodes in the abstract syntax tree. So here we can see that the echo statement, we get the information about the location, where it starts, where it ends. The echo statement itself has an array of expressions, which in this case is just one string, and we can see the value of this string. So this is the tree-like representation of this file, of this array of tokens. Let's take another look at a slightly more complicated PHP script. So we have first a variable assignment, so $conference is equal to LARACON EU. Then we have an if condition where we check if the conference variable value is equal to LARACON EU, we're going to echo something out. Again, we pass it to the tokenizer, or it happens under the hood for us. And because this is more code, we get more tokens. So this is what it looks like. We have the if, more white space, equal signs, stuff like that. So just this huge flat array. And if we then give that one to the actual PHP parser, it transforms this into the abstract syntax tree. And now we can see we have two children. So the first one is the expression statement, which is our variable assignment. Then we can see information about the assignment itself. So we can see the left-hand side of the assignment, the right-hand side of the assignment, what kind of operator was used. Again, all the information where in our source code this happens. Then we have our if condition, where we can see the individual tests. So if you would have multiple tests combined with and or, then those would appear in the abstract syntax tree. And then we have the actual body of our if condition, which is, again, an array of children. In this case, it's just the echo statement. All right, so all of this happens under the hood whenever we use PHP, basically. But things get really interesting if we take this approach and put it into userland PHP code so that we can use it in our own scripts, in our own projects. The most known, or pretty much the only real PHP parser written in PHP, is the PHP parser package from Nikita. There's also from Ryan Chandler, who happens to sit up front. He's working on a Rust-based PHP parser, which is insane. It's super fast. But we're going to take a look at the PHP parser written in PHP itself. And this one is being widely used across the whole ecosystem. So if you use any kind of static analyzer, like PHP-stan, larastan, then this uses the PHP parser. If you use something like PsyShell or Tinkerwell in this case as well, we use the PHP parser, the IDE helper, Rector, as Thomas showed you earlier. So a lot of projects make use of the PHP parser internally. So we are going to take a look at various levels. The first one is just, that's kind of interesting. Then we come to my favorite GIF. So we're going to explore a bit what we can do with the PHP parser. It's a long one. So we make some tinkering with it. We look kind of proud. We taste it. And then we're kind of happy. And, well, we end up with these mad scientist kind of vibes, where we can do whatever we want in PHP. So that's at least the goal, what we want to do in this talk. So let's jump into PHP Storm. This is not a Laravel project. It's just a blank PHP project where I have installed the PHP parser already. And here we have this code variable that just holds our source code that we want to parse. So usually this would probably live somewhere in a file that you would then include and read. So here we just have the OpenPHP tag, and we want to echo hello Laracon. So what can we do with this now with the PHP parser? So first of all, we can create a new instance of the parser by making use of the parser factory. And then we have to specify which version of PHP we actually want to parse, because the parser is written in PHP, and as the PHP syntax changes, the parser needs to understand it. So PHP 5 code needs to be parsed differently, or doesn't even have all the tokens that PHP 8 code has. So we can specify a specific version if you want to do that. We can also say, well, just give me the parser for the newest supported version. And then we can basically parse our code. So we can say parser, parse code, and this is going to return the abstract syntax tree for us. So if I now run this, then we get this array of individual nodes. So as you can see, the node is actually an object. So this is a PHP parser node object. Then we have some metadata about this actual node. So we know where the line starts for this node, where the token position starts, where the file position is, same about the end positions. And then this echo statement has this array of expressions, like you saw in the syntax tree earlier, which now has this string We also have the meta information. And then at the end, we get the value of our string. OK, so like that, you can parse some string of code into the abstract syntax tree, which is kind of cool. But what do we do with this now? So what you can do is you can transform the syntax tree back into actual PHP code. So we can create a printer, which is called standard. So it's the standard pretty printer that comes with the PHP parser. And then we can say printer pretty print file. And then we just give it the array of nodes that we want to print. So in our case, it would be the AST. And if we run this, well, we get the same code that we gave it as an input, because we haven't done anything with it, with the abstract syntax tree. And if you don't want to print it as a file, you can also do pretty print, which just gives you the actual statements inside the abstract syntax tree without the OpenPHP tag. All right. So let's jump to the next level. It's the same code, but this time we want to do something with it. So we already initiated the parser, and we parse it to the abstract syntax tree. And now I want to change the string that says hello LARACON to hello Amsterdam. Now, of course, we could do just some string replays, but let's say we want to do this as we have the parser at our hands. We can do this not only for one string where we know the exact value, we can do this for any kind of string that happens to be in our code. So let's see how this works. The way that this is usually done in the PHP parser is by using what is called a traverser. So we can create a new instance of a traverser like this. So it's a node traverser. And this node traverser, as the name suggests, can traverse the abstract syntax tree because it can be super deep, depending on how your code is structured. And then we can modify the nodes as we go through it. So basically, we can then say traverser, traverse our abstract syntax tree. And this is going to return a new modified abstract syntax tree. In this case, it wouldn't do anything because we're just traversing it without applying any logic. So let's do that next. So we can say we want to add a visitor. So every time we visit one of these nodes in our syntax tree, we want to do something. So we can just give it an anonymous class that extends the node visitor abstract that gives us some helper functions. So here we can basically say every time we enter a node, we want to do something with it. Every time we leave a node, or after traversing or before traversing the whole thing. So what we want to do is we want to have the enter nodes method. So in our case, we want to change the string to hello Amsterdam. So how can we do this? Well, first of all, our abstract syntax tree can contain a lot of statements, like the echo statement. So we want to limit it to only the string. So we can say if the node is an instance of string, well, then we're just going to modify it. So we can say the node value. So the value of our string in our code should be, what does it say? Hello Amsterdam. Like that. And that's it. Because we're working on the objects as references, we don't have to return anything. So we already traverse it. And I just wrote a simple helper function so I don't always have to new up the printer. That is called print.ast. And like that, we now change our string in our PHP code. Now, what's cool about this is, or maybe it's not, depending on how you see it, if we have like a country variable, and we say it's Amsterdam, and we run this, well, we basically now check for every string node in our abstract syntax tree and change that. So if we only want to modify this echo statement, well, we can just modify the if condition. So instead of checking for a string, well, we check for echo. As this is just PHP code, we can check for the individual nodes. So if the node is an instance of echo, we don't want to change the value of the echo itself, but from the first expression, like that. Hello, Amsterdam. All right, so now our country variable is untouched because we're only looking for this string that comes after our echo statement. So the next one is a bit more code. So in Laravel 10, if you remember, we had these config files. And there we have this providers key where we have like the service provider, default providers merge, then we have an array of providers. And let's say that you create a package, and when you install the package, you want to append something to this array. That's, for example, what Nova does. When you run PHP Artisan Nova install, Nova will add its own service provider to that list. They do it by just string replace, basically, but we can also do this with the PHP parser. So this is our code. We already have our traverser. So now we want to append something to it. So we will add a new visitor. That extends the node visitor abstract. And then when we enter a node, well, what exactly do we want to do? So we want to get the node that is the merge method call, and then get the argument of that method call, which is this array, and then append something to this items array. So if the node is an instance of a method call, and the node name as a string is equal to merge, well, then let's get the arguments. So the argument is going to be the node. So the first argument's value, and this is our array. And now we can add something to this array. So we can say arguments, items, and then add something to it. But as we are in this abstract syntax tree land, we can't just add, I don't know, my package class to it, but we need to add a node in this syntax tree. So what we can do instead is we can add a new node, and the one that we want to use is called class const fetch. So what this is actually doing is, these are classes, this is a constant, so we fetch this constant from this class. So we want to add that. So the first argument is a name, which is also a node. So like my package, some class. And the second argument would be the constant that we want to fetch from it, which would be class in our case. All right, so this looks pretty good to me. Let's see. So we still need to traverse the actual abstract syntax tree. So traverser, traverse AST. And then let's print it. OK, so this looks like PHP code, and there it is. So like that, we can now modify the PHP code, but in a more object-oriented approach. Now, the way Nova does it, by just doing a string replace, is perfectly fine. I'm not saying you should always use the PHP parser for this, but I think it's really cool to have the ability to do it, especially if you want to modify PHP code that is a bit more complicated or a bit out of your control, maybe. All right. The next thing is, you probably have seen code like this. So we have a variable, then we dump it, and using something like pests architecture testing, we can ensure that these dumps are not in the code that we ship to production, but it would be cool if we just remove these dump function calls in the first place. And we can use the PHP parser for this as well. So the idea is that we traverse the abstract syntax tree and then remove the node that we don't want. So we can add a visitor, new class, extends node visitor abstract. And when we enter a node, we first have to do the whole check again. So if the node is an instance of a function call, and the node name is equal to dump, well, we want to remove this. So in PHP parser, we can return a special constant for this. So we can return node visitor remove node. And this is then instructing the traverser to get rid of this node entirely. So now if we traverse our abstract syntax tree and then echo it out, we return something invalid. Right, because functions, functions in PHP are actually expressions. So we need to remove the expression that is the function call. So we need to check for an expression. And then the node expression, I think it's like that. Needs to be, oh no. It kind of works like that, though. Well, you get the idea, yeah? I'm just going to skip that one. OK. So this is the last one. So we have, again, just an echo statement. And what we want to do is we basically want to wrap the echo statement in a function call. So this is what we do, for example, in Tinkerwell. If you have some code like this and you run this through PHP Artisan Tinker, then you get this as the output. Because we're just echoing a string and a variable, it will just be one big output buffer that gets concatenated. But it would be cool if we would have the echo calls being displayed as individual cards. So we can actually do this in Tinkerwell by toggling this detail dive feature. And the way this works is we actually modify your PHP code before it gets evaluated by rewriting your code into something like Tinkerwell dump, something like that. Same here. So we modify your code on the fly before it gets evaluated. Then we internally still do the echo, but we can also get the result, store it somewhere, and then display it in the UI. And I think this is really cool that we can just modify PHP code on the fly for this. So let's see how we can make this work if my live demo gods are still with me. So we have the code, we have the traverser, so we need to add a new visitor. New class extends node visitor abstract. Like this. When we enter a node, well, what we want to do is we want to check if the node is an echo statement. And if it is, we want to return a new node instead of this echo statement. So if the node is an instance of echo, well, then we want to return something new. And the node that we have to return is an expression, just as good as it worked with the last example. And well, then we have to return an actual expression, which is a function call. And in PHP Parser, you can manually new up these nodes, but there's also a cool feature called a builder. So we can create a new builder by making a new builder factory. And then we basically can build whatever kind of PHP code we want. So for example, a new, a function call, a concat, a method call, some arguments, a use statement, all of this. And it's really cool. So we want to create a function call. So we can give it a name, like, I don't know, internal dump. And then we have the actual arguments of this function call, which in this case would be the expressions of our node. OK, so with a bit of luck, this should work. So we traverse our abstract syntax tree, get a new one back, and we print it. And there we go. Whew, it worked. Cool. It's cool that you clapped that I didn't fuck it up, so thank you. All right, and this is pretty much all of the time that I have to demonstrate something for you. You can do some pretty crazy stuff with a PHP parser. Yeah, like you can detect if variables are used, if variables are unused, stuff that the static analyzers do. And I know that you're not all going to build the next static analyzer. I know that you're not all going to build the next Tinkerwell, hopefully. So maybe this is not really applicable to your day-to-day job, but I think for me, learning the PHP parser pretty much unlocked a new skill, and it made me think differently about PHP code, and I just think it's a really cool tool to have in your set. So whenever you think something is impossible in PHP, reaching out to the PHP parser probably makes it possible. So thank you very much. I hope you learned something. I forgot about the anonymous user.
I'm really stressed. You don't believe it. Well, I got questions.
Sure.
So, first of all, what Janet, this is a difficult name, Jenier, I don't know, is asking, what's the next plans for Beyond Code?
Heard for Windows. So, I mean, after the announcement yesterday, the timeline was full of people asking for Heard for Linux, because once you give them your, I don't know, the little pinky finger, if that's an English saying, they try to grab your arm. So it's definitely Heard for Windows. There's a lot that needs to be done.
No pressure.
Yeah.
And
just for stuff.
For the anonymous user, lastly, because he needs to go home to his wife and kids, he's asking, when are you going to appear in the Lord of the Rings movie?
I think I need to get older, get more beard again, and become gray. So still takes some time.
Okay. Thank you a lot. That was Marcel.